All right, we're going to look at polygons, perimeter, and circumference. So, kind of a lot in this video. So, first thing is to identify polygons. So, poly means many, and I think gons means sides, many sides. So, here's just a few of the common shapes. So, if it has 3 sides, we call that a triangle. If it has 4 sides, we call it a quadrilateral. Now, there are several quadrilaterals, and they might be listed below, so I'll come back to that idea. 5 sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. And 8 is an octagon. Now, it can go on further. There's a nonagon, a decagon, a dodecagon. I think there's a dodecahedron. But these are the most common ones. So with quadrilaterals, that's a big category because there are lots of shapes that have 4 sides. So here's a few of them. So we have a trapezoid. We have a parallelogram, a square, a rectangle, a rhombus. I think the only other one that I think of that's not on here is a kite. I don't think I did a very good job of drawing that. We usually have 2 pairs of congruent sides. All right. So let's look at this figure and try and identify what shapes are in here. So the first one I see is 1 and 5. And those have 1, 2, 3, 4, 5, 6 sides. And 1, 2, 3, 4, 5, 6 sides. So those are hexagons. I'm just going to label them like this. 1 and 5. All right, next thing I see is this big old trapezoid here. I'm going to look for any more, and I don't see any. All right, I'm going to erase this stuff off. I'm going to start marking off the numbers so I know what I've looked at. So I've done 1, I've done 5, I've done 11. And I see 8 and 17 look like parallelograms, potentially even a rhombus. So I'll say parallelogram. 8 and 17. I don't know that all sides look the same, so I'm going to call it a parallelogram. And then I think the rest of them, as I'm trying to look at them, I think the rest are triangles. So triangles, the rest of them. So it looks like the highest number was 17, so I'll just fill out the rest. So I already have 1, 5, 11, 8, and 17. So 2, 3, 4, already have 5, 6, 7, already have 8, 9, 10, already have 11, 12, 13, 14, 15, and 16. That should cover the rest of them. All right, being able to identify what kind of shapes they are is going to help us when we go into this idea of perimeter and area of shapes. So perimeter, I call it the fence around the shape. I think a better, formal definition would be the distance around a figure. But I think as you talk about it over the years, I think another good definition for perimeter is telling what we do. So adding up all the sides. So there's not one set formula for each shape. So if we just remember that it's adding up all the sides, then we're good to go. So something particular about regular figures, and I'll even write that out here. Regular polygon. That means that all sides are congruent or the same. So I have a regular pentagon here, and one of the sides is 7, so that means all of the sides are 7. So I can add them all up. I can say 7 plus 7 and do it 5 times for the 5 sides, and I'll get 35. Or I can say, hey, I have a side length of 7, and I have 5 of them, so I can do the multiplication. 7 times 5 is 35. Okay? So either way, it works nice when they're regular figures because I can just do that multiplication. Because like here, I have 8 sides, and both of these are 14, and that means the rest of them will be 14. So I could add 14 8 times. Or I could say, hey, the side length is 14 and there's 8 of them, and I can do that math. So let's see, 14 times 8, I'm just throwing that in a calculator, is 112. I guess I should be proper here. It's in centimeters for both of these, so throw in those units. I find the perimeter of a square table that measures 30 inches across from one side to its opposite side. So, all right, I'll just draw a little picture. Got a little square here. Each side is 30. So I could add 30 4 times, or I can say my side length is 30, and I have 4 sides, and that'll give me 120. And this time it's in inches. Right, I have a irregular polygon here. Let's see, how many sides does it have? 1, 2, 3, 4, 5, 6, 7, 8. So I guess we could call that an octagon. It's got 8 sides. We want to find the perimeter, so we might have to do a little bit of math. So I know some of the sides, but I'm missing this side, this side, this side, and then this one. So this length here is 4, and that's the same distance here. So that's 4. Similarly, this side matches up with this side, so that piece is 3. And then this entire side is 12, and I know that this chunk of it is 4. So 12 minus 4 is 8. And it looks like it's right in the middle, so I can split 8 into 2 pieces to get 4 and 4. Well, I don't really need that because I know that this whole distance is 12. I really just needed to know this extra piece here. And now I can add up all the sides. So here's what I'm going to do. I'm going to group them a little bit easier and say there's 12. And then there's 1, 2, 3, 4, 5 pieces that have a measure of 4. And then there's 1, 2 pieces that measure 3. And then I'll see what that adds to. So let's see, that's 12. 4 times 5 is 20. And 3 times 2 is 6. And then 12 plus 20 is 32. 32 and 6 makes 38. All right, one thing we haven't talked about is the interior angle sums and the exterior angles. So we talked about before the triangles and that the sum inside a triangle is 180. So this is a nice little formula to tell us what the interior angles are. N is the number of sides. So if I use this formula with triangles, there's 3 sides in a triangle, right? So 3 minus 2 and then times 180 degrees. So 3 minus 2 is 1, and then 1 times 180 degrees is 180 degrees. So if I do another shape, like a rectangle or a square, that has 4 sides. So 4 minus 2 times 180 degrees. Well, 4 minus 2 is 2. And 2 times 180 degrees is 360 degrees. So what I'm going to do is I'm going to draw a little picture here. I'm going to take this vertice, doesn't matter which one, and I'm going to draw a line segment from the first vertice to every single other vertice. So there's one, and there's one. So what I did was I divided it into triangles, and there's 2 triangles. Well, if we know that one triangle is 180 degrees, well, I have 2 triangles. So I'm multiplying it by 2. You can see that with the vertices, I share a side with 2 of them. So that may be y minus 2. I'll do another shape. So I'll do a pentagon. I cannot draw a regular one. So this is what my pentagon looks like. I'm just going to pick this vertice, and I'm going to connect to every single one of them. So there's one, there's one, there's one, and there's one. So do you see how I share 2 sides that are already included? And I have 1, 2, 3 triangles. So notice if I did the formula, 5 minus 2 gives me 3. And I'd multiply that by 180 degrees to get that interior angle sum. We'll fill out the rest here in just a second. So there's also exterior angles. So exterior angles, I'll pick this vertex I was just drawing on. This would be the exterior angle. If I drew here, I can draw another dotted line. There's the exterior angle. And I can keep going for each of the vertices. So this only works for regular polygons here, this formula. So we would take 360 and divide by the number of sides. So if I had a square, that has 4 sides, right? So 360 degrees divided by 4 gives me 90 degrees. Should kind of make some sense because we should know that a square has all right angles. So its exterior angle would have to also be 90 because it makes a straight line. So if I gave this pentagon angle measure here, let's see, let me erase my drawings. Let's say I gave this a measure of 120. Then the exterior angle is the difference between that and 180. And then if all of the interior angles are different, then those exterior angles are going to be different. So that's why this only works if you have a regular polygon. I'm going to erase some drawings here. So a quadrilateral, we did the formula earlier, and we get 360 degrees. A pentagon, I started it, but I didn't finish it. So that was 3 times 180. So that's 540 degrees. Hexagon, so that's 6 minus 2 times 180. So that's 4 times 180, so 720. And then an octagon, it's 8 minus 2. So that's 6 times 180. And then a triangle, that really should have been the first one, but triangle, 3 sides minus 2 times 180 gives us 180. So now knowing these facts, let's find some angles. So 1, 2, 3, 4, 5. So if I go back up here, it's a pentagon, so they all add to 540 degrees. So I'll write that equals 540. So I'm going to add all of these up. So 120 plus 6x plus 25. I think I'm going to run out of room. I'm going to redo that right here. 120 plus 6x plus 25 plus. And with the rest of these, I'm going to distribute these values in. So 5 times 2x is 10x. 5 times 5 is 25. Do it with this next one too. So 5 times 3x and 5 times negative 5. So 15x and minus 25. And then this last one here, 5x and 35. And all of that adds to be 540 degrees. And then from here, I just want to solve for x. So I need to combine any like terms. So I usually start with the x term. So I'll combine those. 6 plus 10 plus 15 plus 5. So let's see, 15 and 5 makes 20. 20 and 10 makes 30. 30 and 6 makes 36. So 36x. But then I have these numbers, or these constants, that are also like terms. So I'm going to combine those as well. That one I might need a calculator for. 120 plus 25 plus 25 minus 25 plus 35 gives me a grand total of 180. And all of that still equals that 540. So what I'm going to do now is I'm going to solve for x. So I need to subtract 180 from both sides. And let's see, 540 minus 180 is 360. And then I'll need to divide both sides by 36 so that x is 10. So then I can find all of the angle measures now. So one of them's already done for us. It's 120, so that's nice. But I now know what x is, so I can solve. So 6 times 10 plus 25. Let's see, 6 times 10 is 60, plus 25 is 85. And then I have 5, and then 2 times 10 plus 5. So 2 times 10 is 20, plus 5 is 25. 25 times 5 is 125. And I have 5 times 3 times 10 minus 5. 3 times 10 is 30. 30 minus 5 is 25. And 25 times 5 is 125. And I'll do this last one here. We got 5 times 10 plus 7. I'm getting ahead of myself there. So that's 5 times 17, which gives me 85. And there's all the measures of those angles. All right, last idea here is circumference. So it's just a fancy word for perimeter of a circle. So this one has a specific formula because we don't have like sides, right? A circle is this round object. So there's not really any sides to add up. So we have these formulas here. So circumference is pi times diameter, or the circumference is 2 pi r. Because in a circle, I'll even write, okay, D is for diameter. I'll draw a picture with that. How about that? Diameter goes from one side of the circle to the other, and it goes through the center. So if I were to draw a line from here to here, I can't call that a diameter because it didn't go through the center. And then R is for radius. And a radius goes from the center of the circle to the outside. So it could be there, could be here, could be there. And circles, the radius is the same throughout. I did not draw a perfect circle because I don't have that skill of drawing a perfect circle. But the distance for radius should be the same throughout the whole circle. And there's a special relationship between the radius and the diameter, which is why we have two formulas here. So the diameter goes all the way across. Well, if I look here, if I just looked at this right part here, that's a radius, right? I'm going to draw an even bigger circle here. I had a professor once, and I say professor, he's a high school teacher. He could stand at the board, take his arm with a marker, and draw a perfect circle every time on the board. Now that was pretty good, I won't lie. That one, I at least had my lines connected. Yeah, he could draw a perfect circle every time. So here's my diameter. If I use the center of the circle, the radius is supposed to be the same on each side. So that's a radius, and that's a radius. Almost looks like a face, and that the R's are the eyes. So the diameter is 2r. Or the radius, could divide both sides by 2. The radius is half of the diameter. So that's why we have two relationships here. Because if I substituted, instead of diameter, if I did, well, I'll go this way. Instead of saying 2 times the radius, well, the radius is half of the diameter. And this 2 and this 2 would cancel out. So I'm left with pi times the diameter. So we can use these formulas interchangeably. I guess I haven't really said what pi is. Pi is a symbol, and the way we use it is we approximate it as 3.14. It's an irrational number that keeps going on forever and ever. There's no pattern and there's no repeating. But we just use 3.14 as an estimate for it. So that's what we'll use in the calculator. So find the circumference of a circle with a diameter of 10 centimeters. So because I have the word diameter, I'm going to use the circumference is pi times the diameter. So circumference is pi times the 10 centimeters. Now I could rewrite this as 10 pi for an exact answer. Or I can do 10 times 3.14 to get an approximation. So 31.4 centimeters. I'll try another one. Find the circumference of a circle with a radius of 2.25 centimeters. So I can use the other formula. So circumference is 2 pi r. So circumference is 2. I'll just go ahead and throw in the 3.14. 3.14 and then times the radius, so 2.25. And then I'll just multiply those three numbers. So 2 times 3.14 times 2.25. And I got 14.13 centimeters. We can work from a backwards perspective and say, oh, let's find the radius if we know the circumference. So, all right, let's use the circumference as 2 pi r and fill in what we know. So we know the circumference. I'm going to move over here so I have some more space. So 15.71 equals 2 pi r. And now I want to get r by itself. So the 2 pi is held together with multiplication. So we can undo it with division, because then those will cancel. We're left with r equals. We're going to divide this side by 2 pi. So we're going to type this in the calculator. And what we want to type in to make sure the math works out is we want to do 15.71 divided by, and then throw parentheses in, because we want that 15.71 to be divided by the 2 times 3.14. If you did not put parentheses around it, oops, then your calculator does this. It does 15.71 divided by 2, and it gets an answer, and then it multiplies it by 3. And that's not what we want. We want those two to stay together. So let me get that answer. 15.71 divided by parentheses 2 times 3.14, and then close the parentheses. So that gets me 2.50159. So I'm just going to leave it at 2.5 centimeters. Let's do another one. So find the radius of a circle with a circumference of 12. So same formula, C equals 2 pi r. I know the circumference, it's 12. And then 2 pi r. So same idea as the last problem. Divide both sides by 2 pi so that we can get what r is. And make sure we're typing it in correctly. So 12 divided by parentheses 2 times 3.14, which is 1.9108. So I'll just do 1.91, and then we're in inches this time. Now it could say, what's the diameter? Like that could be a follow-up. So we could just multiply that number by 2 to get the diameter. All right. And that is it for this little section. So if you have any questions, let me know.